Werner H. Turgeon, Professor Emeritus UCLA. Specializations: Energy Budget Physics, Global Climatology, Urban Climatology, Bioclimatology and Photosynthesis of Plants, Models in Crop Water Budgets and Plant Growth for the World. No specialization in astrophysics, but I am conversant with the subject. We define that universes are subsets of the cosmos. Then, some propositions. Time is an illusion. Reality consists of an infinity of event frames. Stacking up event frames in a sequence is like running a movie projector. At a certain speed, we perceive seamless motion and passing of time. The human mind is currently engineered in terms of beginnings and endings and ideas of creation. Realities are quite different. They are probabilistic on an infinite scale. The response is awesome. All the event frames exist all the time. Visualize an infinite matrix. That matrix has always existed. There is no beginning or end. No creation. It is literally everything. It always has been. We will try to visualize the infinite 3D matrix of event frames, or bubbles, all direction, x, y, z, and in infinity. Part 1: Metaphysics of Singularities. Propositions. A singularity is an uncertainty, chance event, and is scaled in probabilistic terms in percentages. That has long been accepted. Our changes have gone beyond this traditional concept. Singularities are everywhere, in geophysics and human affairs. In the latter, empirical hindsight, knowledge reigns. Foresight statements are speculations only. Time and cause and effects are illusions. A maker of singularities, which could be, for instance, astrophysical, black holes, big bangs, ratio matter versus antimatter, ratio dark matter versus dark energy, geophysical, asteroids, volcanism, biological, punctuated evolution, species radiation, cultural, seminal astronomical observations, belief systems and social revolutions, financial disasters. The Kurzweil singularity is biophysics. In order to avoid using the time word, X became forward and backward. Y became leftward, hindsight, and rightward, foresight. Z became upward and downward. Several statements seem to be in order. The only certainty is uncertainty. Singularities seem to be the agents of change in the cosmos. How do we quantify this? We use basic statistics, which withstood the test of time. The least, or less, probabilities are residing in the astrophysical sector. For instance, a Big Bang seems to happen only once at the beginning of a universe. Other, rare singularities occur in the universal constants, dark matter, dark energy, matter, antimatter. The geophysical sector has higher singularity happenings, but time intervals are still large. The biological sector is about halfway between the two extremes. The Kurzweil singularity is different in regard to its placement. It is both biological and geophysical, and, because of strong exponentiation, has been moved near the most likely probability location. The cultural and social sections have the highest singularity incidence. These singularities changed history from a monotonous sequence into a more punctuated and ever-changing panorama. The sciences might want to refocus on the study of the many natures and types of singularities. So, folks, get out of your self-indulging certainty boxes and be buffeted by the winds of change and uncertainty. We are dealing with extremely large differences in size. The range extends from infinity, the cosmos, to tiny subatomic particles, to about 10 to the minus 30. Below the cosmos, in contrast, the big players, universes, have the least probability in the formation of singularities, whereas the opposite is indicated among the tiniest of particles. The tail is wagging the dog. Thus, the greatest uncertainty is governing the formation of infinite realities. The cosmos is infinite. It has no beginning or end. It always was. There is, or was, no creation. It is everything. It contains every possible probability. Even the most bizarre realities have at least one occurrence. Universes are born by Big Bangs of an infinite number, all possible types, durations, universal constants, and sizes. A constant, ever-ongoing, bubbly change. Where is our current universe in all this? Clustering is a key feature in a universe's modification. Singularities. Clustering can be firstly nebulae, secondly galaxies, thirdly supernovas, fourthly stars and solar systems, and fifthly planets and inclusions. There are many types, sizes, and many reclusters. More reclusters result in increasing number of elements, including those which make life possible. Universes which are clusterless are drastically different from our own universe, there would be no galaxies, stars, etc. So, it is important to clump or not to clump, that is the question. Here is an example of a preplanetary nebula. Again, there is an infinite number of nebulae, types, and sizes, as well as universes without nebulae. Black holes and galaxies. The first singularities, or black holes, of varying sizes and types. The responses, or galaxies, which are clusters of stars, star remnants, gas, dust, clouds and dark matter. There are many sizes of galaxies, dwarfs of only 10 to the 7th stars to giants, 10 to the 14th stars. There are also large gaps where only gas, dust, and cosmic rays exist. Black holes are the drivers of mass and momentum motions. Another powerful actor is dark matter, which is about 90% of the galaxy's mass. This massive gravity keeps the system together. There is an infinite number of black holes, galaxies, types, sizes, and inclusions. Supernovas can be recyclers of previous nova singularities. There are novas and supernovas. The latter is much more extreme and visible throughout a galaxy or beyond. The explosion shockwave moves at 10% of light speed into space. There are types 1 and 2 and their subdivisions. The former is an old star that collapses by gravity into a neutron star or black hole. Type 2, a white dwarf, inputs material from a neighbor star, rising its core temperature into a runaway nuclear fusion. It appears that supernovas average every 50 years in our galaxy. But no supernovas have been observed since 1604, since Kepler's observation. Supernovas too close to our vicinity in our galaxy could be very destructive. Several paleogeological extinction events have been traced to deadly gamma-ray outbursts. Again, there are an infinite number of novas, supernovas, types, sizes, and material recyclers. Star formation in the Rolf-Dioicke cloud. Spitzer Space Telescope, IRAC, MIPS, NASA, JPL Caltech. Star systems are subsets of galaxies and supernovas. They range from single, binary, triple, quadruple, quintuple, sextuple, to septuple. The most common systems seem to be single to triple. All are held together by gravity. Sizes range from tiny to very large. There are an infinite number and sizes of stars and solar systems. Plants and inclusions. Planets and their inclusions are subsets of solar systems. The inclusions range from moons, asteroids, comets, meteoroids, meteors, dust, and human detritus. Sizes range from tiny to large. There are an infinite number and sizes of planets and their inclusions. Human egg cells are subsets of all bioorganisms. They are the smallest building block of life. About 10 trillion cells are in an average human. Cells can range between 1 and 100 micrometers. Prokaryote and eukaryote cells are the basic types. Both have many inclusions, including DNA, RNA, and organelles. There is an infinite number of sizes and types of cells. Water molecule H2O. Molecules consists of several atoms in an electrically neutral group, held together by covalent chemical bonds. They may contain atoms of a single element like oxygen, or different elements like water. Organic substances are common in the atmosphere and oceans. The majority of molecules are very small. For instance, the smallest molecule is diatomic hydrogen, H2, which equals 0.75 times 10 to the minus 10 meters. Most molecules are several times larger, up to a dozen of that number. It is not surprising that there is an infinite number, sizes, and types of molecules. A depiction of the atomic structure of the helium atom. The darkness of the electron cloud corresponds to the line of sight integral over the probability function of the 1-second atomic orbital of the electron. The magnified nucleus is schematic, showing protons in pink and neutrons in purple. In reality, the nucleus and the wave function of each of the nucleons is also spherically symmetric in 1 second, and the 4 particles, each with a different quantum number, like the electrons in the helium atom, are almost likely to be found in the same space at the exact center of the nucleus. In simpler terms, we have entered the quantum uncertain size section. Here, uncertainty reigns. Thus, an electron's speed and/or location cannot be determined at the same time. Statistical physics have to used to determine probabilities. This realm of probabilities is the mother of an infinite number of sizes, types, and, yes, probabilities. Electrons, protons, and neutrons. The smallest of the small. This is the grandmother of an infinite number of sizes, types, and probabilities. If we use the scale given to the neutrons and protons, Then, the quarks and electrons are less than 0.1 meter in size, and the entire atom is about 10 kilometers across. This means that almost all of the atom is just space. Our reality is empty space. The statement, bubbles within bubbles, needs some clarification. A clearer term for academics would have been subsets within subsets. Yet, for the general public, the bubbles term is perhaps more understandable. So, the subsets to the infinite cosmos are universes. Ours is one of them. Compared to the other subsets to follow, they are large. Each universe has many subsets of nebulae, which are quite smaller than the previous subsets. Nebulae have subsets of black holes and the associated galaxies, another size, decline. And so it goes. Subsets get smaller and smaller, ultimately to very small. It appears that the general public's perception is limited to solar systems, to planets, and to cells. The other categories are not well understood. Computational considerations. The basic algorithm for physics singularities is the function of probability of a singularity event, kurtosis, skewness, size. This means, among other things, that we are not just using regular, bell-shaped curves, also several deviations from that norm. Also we are considering the nature of the curves themselves. For instance, the two parts of the curve of less than 13.6%. These are foreshocks and aftershocks, meaning that some events develop which lead to the following singularity, as well as aftershocks of a singularity which could be considerable and lengthy. Example of foreshock and aftershock for a bell-shaped curve. Example of a possible singularity coalescence in a two-dimensional environment. Notice that in this case, the singularity surface does not reach zero. This may not be always the case. Example of a possible singularity coalescence in a three-dimensional environment. Here, most of the singularity surfaces stay above zero. We are giving an example of a possible distribution of sizes and their probability to be chosen by chance. This was not a real simulation. The idea behind it is that the largest sizes will have lowest probabilities to be selected, whereas the smallest sizes will have the highest probabilities to be selected. The values we are using are rough averages. In reality, many of the items have large deviations from the used averages. A world, universe, galaxy, plants, human affairs, etc. would be a featureless tabula rasa and monotonous, really boring. Singularities, take away this monotony. It is the creation of the many features we are used to see. An example of 3D geophysical system, a combination of determinism, certainty and singularities, uncertainty. 1. Size relative percent. The bigger the size, the smaller is the percent of being chosen. This inverse system is deterministic, deductive process response, white box certainty. It contains leftward hindsight, empiricism. It is non-monolithic. Its most deterministic sector is in the physical biophysical, hard sciences, whereas the social sciences, arts, and humanities sectors show an increasing softness. Nevertheless, the examined life is preferred over speculations based on ignorance or superstitions, e.g., faith-based certainties of extremist religious, cultural, and political belief systems. The former sector goes under the rubric of academia. In spite of its apparent influence in modern society and in considering that the human population is almost 7 billion, the size of academia in it is tiny and still further diminishing. This is because the vast populations of the Third World are poorly educated and ignorant. This portion of the human population has had always a much higher birth rate than the industrial world. This is not a static situation. The earliest mathematical attempts in geometry and algebra appeared in the antiquity. Yet, by far, the vast public sectors were totally ignorant and steeped in superstitions and controlled by theocracies and/or monarchies, using an active priesthood to control their subjects by keeping them ignorant. Only with the dawn of the Industrial Revolution, 1712 AD, did we have the beginnings of modern science and development and associated profound social impacts, including Bismarck's compulsory education of the masses. But the percentage of educated people versus the uneducated keeps on widening exponentially. It is a function of their larger birth rates, lower infant mortality, increased influence of fundamentalist religious anti-science efforts in schools dedicated to indoctrination to keep students obedient to its tenets and mores. Virtually all the major organized religions of the world have schools of this nature. In addition, one should not underestimate the impact of Luddism and its rejection of anything new or different. There are other problems impinging on the education of the masses, even, if not especially, in the industrial world. Twitter, and a large number of other social networks supply an exponential vast amount of information of the blandest quality. But information is not knowledge. To be fair, professionally it could be the first step, empirically, in the eventual evolution of actual knowledge, complete understanding, not memorized information. Consequently, we experience many changes in this supposedly deterministic and certain sector. Is there even uncertainty in certainty because of continuous changes? Determinism has a frazzled edge of trying to predict the unpredictable, i.e., chance events. Creation of singularities. Dark blue is less than 1 standard deviation from the mean. This is about 68% of the set. 2 standard deviations from the mean, medium and dark blue, account for about 95%, whereas 3 standard deviations, light, medium, and dark blue, account for about 99.7%. Originally, other shape factors beyond the bell-shaped versions were investigated. Kurtosis and skewness. Positive skewness. Negative skewness. J-shaped. Reverse J-shaped. Bimodal. Multimodal. But we found them not compelling enough for use at this time. Singularities are totally disconnected from determinism. They simply do not know of each other. They are in the realm of the throwing of dice. As an example, every person, or any event at any scale, is a singularity, created by chance. They may be very small and unimportant or very large and important. Predictions of uncertainties, singularities, may not be very productive. Of course, a certain probabilistic prediction will reoccur eventually. But how meaningful is this? We have to learn to think in terms of singularities in all of the disciplines. This will take some experimentation by experts in various disciplines. In this mind experiment we are only pointing out all the possible ways to influence future research in the different fields to think in terms of singularity creation and existence. There is a singularity ocean in 3D. A crude analogy would be islands and continents of determinism floating in the singularity ocean of uncertainty. They are oblivious of each other. Observational evidence. The evidence is all around us. There is a frazzled edge around determinism, the inability to be completely precise. Everywhere, in the hard and soft sciences, we find events which are not predictive. They just happen. The unpredictable earthquake, or stock market, or elections, or disease, or Beethoven, or the Beatles. And the beat goes on. And what is unpredictable and unknowable? Singularities. The height and shape of singularities also applies to the soft sciences. For instance, in history the height of a singularity is determined by the percentage of the relevant public which is aware of an event or events. Below is a demonstration of the possible shape of singularities in regard to the French Revolution. This portrayal is strictly speculative. At the human level we are all walking singularities. Virtually every moment in our daily hurly-burly is created by the throwing of the dice. Are we getting up at exactly in the morning? What do we do next exactly? It goes on ad nauseum. Seemingly, these are not important events, but many are or could be. The power of dice throwing is fundamental and enormous. This is an example of the application of a sequential arrangement of the preceding French Revolution demonstration example. The bars represent the various sizes, heights of each singularity, the center of each bell-shaped curvature. The red bar stands for the French Revolution singularity. The tan-colored bars stand for singularities from the left ward to the right ward in regard to the French Revolution singularity. Redefining uncertainty. So far, the tradition of treating uncertainty, singularity as statistical entities has been followed. This isolated, the concept of uncertainty from the rest of the sciences. Now, this thought experiment of uncertainty is semantically redefined in relativistic terms. It becomes part of the space-time continuum by defining it as the weight of uncertainty bearing down on us. Similarly, Newton's force of gravity was redefined by Einstein as an effect which depresses space-time. So does relativistic uncertainty. RU. The units of RU are kilogram times meter squared times seconds squared minus 2. Initially and experimentally, RU is related to each probabilistic percent that corresponds to each percentage point, 1% to 99.9%, or 1 RU to 99.9. There could be multiples of this, later to be explored. Consequently, one can state now, determinism plus relativity plus uncertainty equals 0, or certainty plus uncertainty equals 0. This expression is deceptively simple, hiding a massive amount of possible calculations. The devil is in the details. This system of equations in energy, mass, momentum, and RU creates an environment of physical and social viscosity similar to Einstein's treatment. Everything in the cosmos, with multiverses, experiences viscosity. There is no true vacuum. It becomes a non-compressible fluid, with possible time dilations of mass increases, contractions in the direction of travel, and the slowing down of time. High viscosity, e.g., Luddism, socio-religious certainty, effects of gravity, etc., slows down momentum, be it physical or cultural. Computational considerations. Total certainty is the antipole of total uncertainty. The latter begins at less of the nano-level, atoms, the realm of quantum mechanics. This has been treated before. The regression equation y equals minus 8 times e times minus 31 times x plus 0.8 predicts this relationship between the two poles. In the Cartesian diagram, x is the size in meters, whereas y is the uncertainty. Total certainty, or total determinism, may need some definition and/or explanation. A process-response system, situated on a slope, is used to explain the forces of energy, mass, and momentum acting on this selected cube. A human-related graph portrays the extremes of human total ignorance to total knowledge, using Kurzweil's Homo connectus idea of exponential development of knowledge. The agricultural revolution, about 10,000 years ago, began the first settlements in the opportunity of learning. The remaining Homo sapiens are thought to be undergoing the geometric development, climbing gradually through the ages. The two curves or virtually the same, for many centuries, and began to diverge since the Renaissance. Yet, there are numerous current scientists which view the future in geometric terms. The exponential regression curve is y equals 0.0490 times 1.5009 times exponent x. As seen by an outside observer, this graph deals with the relativities of time dilation, time increases, length contraction, and mass increase. All three react to velocity increases. At slow speeds, Newton's laws are still reliable, but at speeds more than half the speed of light, time dilation increases exponentially. It approaches 1, never to reach it. Length contraction is in the direction parallel to its motion. This shortening of length is the Lorentz transformation. It approaches 1, but never reaches it. Mass increases act similarly. It increases to approach infinity, but never reaches it. Thus, one cannot exceed the speed of light. The exponential curvature is the same as used in the previous Homo erectus graph. This graph had been derived differently based on simple assumptions. Wikipedia shows the basic tools of the Navier-Stokes general equations, which are often used to solve for the viscous space-time effects. The literature offers various methods for finite difference solutions for these equations. Final remarks. It is realized that the results of the thought experiment were somewhat radical. Because of this, it will undergo an almost automatic negative lattice rejection. The bell-shaped curve indicates at least a 50% rejection under the best of circumstances. The next following continuum will be from mere tolerance to mild acceptance to full acceptance. Academic folks will have a hard time to assimilate the use of singularities or unknowables as constant uncertainty companions in everyday life, and in the sciences, the singularity ocean. This would have affected the social sciences, and especially the humanities, arts, etc. I have to admit that all of this did not come to me easily. My background has always been deterministic. I did my mind experiment, one step at a time. There was no agenda. Logic just drove me to it. Uncertainty. The idea that, for example, at the human level, we are all walking singularities is a hard one to swallow. Let us face it, virtually every moment in our daily hurly-burly appears to be created by the throwing of the dice. Are we getting up at exactly in the morning? What do we do next exactly? Seemingly, these are not important events, but many are, or could be. The power of dice throwing is fundamental and enormous. Consider how this is received among the certainties of the religious, political, cultural, devout. It is dynamite, but the search for realities cannot ignore uncertainty. We cannot say, "Not in my backyard." All these considerations drove me to examine the possibility of divorcing the idea of uncertainty from statistics, to be able to communicate with the deterministic universe and cosmos. To achieve this goal, uncertainty was redefined as relativistic uncertainty, U sub r, a weight with mass and momentum bearing down, having the same units as the relativistic universe cosmos. For convenience, RU is relabeled into U sub r. This led to determinism plus relativity plus uncertainty, U sub r, equals 0. Since the first two items are based on certainty, it becomes certainty plus uncertainty, U sub r, equals 0. It attempts to put all knowledge under one umbrella. Initial results show that U sub r can change from maximum 1 to minimum 0. It is a subject to time dilation, mass, and length changes, just like certainty. U sub r is independent of the assumptions that time and cause-effect are illusions. Scientific ignorance is widespread. People and their elected representatives make choices in scientific subjects with ignorance, and they are not mindful of the dire consequences.